Okay, so chapter 5 is about the techniques of methods design. So here we're going to study the product flow in Macromotion. In Macromotion, we study the flow of a product as it moves through the facility. So we consider people, machine, and tools. They are the condition in facility. So this is cost reduction formula. And this is actually like a model, and here we ask questions: why, what, when, who, where, and how. For each operation: transportation, storage, inspection, and delay. And we do this to find out if we can eliminate, combine, reroute, or rearrange, or simply all of this. Flow diagram is a diagram, and it shows a path traveled by a pod or several parts from one point to another in the facility. We study cross-traffic to see if we can remove congestion in the plant, backtracking to see if we can rearrange the lead backward motions in the flow. We analyze distance traveled to choose shortest route, and then we see procedure to choose cheapest production. So this is a flow diagram, and it is a diagram for current grill casting flow in their facility. We usually start with drawing a layout like this, and for just current condition, showing the present method, and we use overlays for a complicated layout if it is necessary. Then we plot each assembly. We use lines, color codes, arrows, and shapes. We finally draw the connection of each flow part. So these are the dotted lines here, and then arrows. This is a flow diagram of proposed method. Here we move the receiving and store to the back end. So you can see right here, which is different from before. Before the store was right there. Now we move it right here. So this design shortened the routes. So you can see the routes are now very simplified, and we simplify them to save the production cost. This is the outline of step-by-step flow diagram. And if we recall, we start with the layout. We use the overlay for the complicated layout. We plot the assembly line using these, and then we draw the connection of each flow. Another chart is the operation chart. And here in this case, we use a cycle for each operation required to fabricate, to assemble, and to pack out. Example is on the next slide, and it's for OC water valve, and they have operations for 6 parts for assembly. So if we look at it step by step, we start with horizontal line right here. Then we do vertical lines, these ones, from each part from top line. Then we add operation cycles for each part. And these operation cycles are on the vertical line. At last, we connect all down to the assembly line. Start with the first part from the far right. So all the vertical lines are going to march into the assembly line one by one. For buyouts are on a horizontal line, so here above the assembly cycles. And here is how to fill operation cycle on a chart. So in the cycle, we just add the operation number. The line bar here, fill above it the production pieces per hour, fill below it the hour per 1,000 pieces or units. So the hour per 1,000 pieces is just equal to total hours it takes to make 1,000 pieces. Next one is process chart, and this chart is used to show all the handling, inspection, operations, storage, and delays of parts from receiving all the way to shipping in the facility. And we always draw it in pairs, like present chart and proposed chart. So the process chart uses symbols or codes. They are here: circle, square, arrow, triangle, and a big D. So the circle is operation, doing a work on a part. Square is inspection for quality control. Transportation is arrow for moving material. Storage is triangle for storing material long term. And delay is a big D, and it's for storing short term. So how to fill it? So first fill 1 of 4, and then do 7, which is your flow diagram. You just have to build the flow diagram and attach it. Then you do 8 to 15 here, and then you do 5 and 6 in a proposed chart. So 11 all the way to 14. So 11 is nothing but your distance in feet. 12 is the quantity. 13 you will calculate and add the time in hour per unit. And for 14 we calculate and add the cost per unit. So that is hours per unit times average labor rate. And in 15 we add either time or cost calculations. So in 1 is the method, either current for now or proposed one with improvements. And in 2 we fill the date, and in 3 is about the part for production, and 4 is for your operation type. Then you do process details. Add method of how you do that process. Shade the process symbol, operation, transport, so and so. In 11, fill in the distance in feet. In 12, the quantity. In 13, calculate and add time in hour per unit production. And in 14, calculate and add the cost per unit. So that is hours per unit times average labor cost. And in 15, add either time or cost calculations. So in this example, for present method, we have like 21 steps. I cut it out here, but it goes all the way to 21. So here I'm going to pick a process, move to stores. So how do you read it? Is process step 2, which is move to stores, is done by fork truck, and it is a transport. So we shade here, and it moved 125 feet. 120 units is your production quantity, and we're doing at 0.023 hour per unit production, and we spend $0.0025 per production unit. So the time spent is 2.5 minutes per pallet production. So then here in proposed chart, we eliminated 15 steps because now we have only 6 steps from 1 all the way to 6. It's a very aggressive elimination of process steps. So here I can pick step 1. So process step is unloading, and it's done by hand manually, and it is an operation, so we shade the operation, and it takes 0.031 hour per unit production, and we spend $0.00217 per unit, and this time we're gonna describe the cost, and that's $7 per hour. So finally, in step 5, we do summary and add the present and proposed with their difference for all jobs from operation to storage. Okay, that's present, proposed, and that's their difference. So here we get 1.137 as difference between present and proposed methods for operation improvements. Okay, 1.137. We don't usually put the decimal here, but when you read, you know that this is the third, second, and the first decimal points. We have 8 operation in present method. It's right there. And we spend 2.454 minutes. And we have only 4 operation in the proposed method. And we spend 1.315 minutes. So the difference is 1.137 minutes, and that's your improvement. And we can translate this value and use it to get cost savings. And in 6, we do analysis by asking each question to each job. Flow process chart uses all 5 process chart symbols. So the only thing new here is buyout parts are treated as manufactured parts. Flow process chart is nothing but operation chart plus the process chart. So you do the first chart, second chart, and that is called flow process chart. So here's an example of operation process chart for telephone stands. So charting it is first you for flow process chart, we build the operation charts like this, and then we build a process chart, the one that I showed you before, this, and we combine operations and process chart together, and then work on all buyouts as manufactured parts. Work cell load chart. So this chart is used only for a few multi-machine special operations, and it contains a layout and a chart. This is a layout for work cell, and we have 5 machines, 2 drills, and 3 holes, and 1 operator, and 7 work elements. So please note here all work elements are numbered by even numbers and in and out boxes. So here you can see 2, 4, 6, 8, 10, 12, 13. And they're all work elements, 7 of them. And these are my machines, okay? And here, this is just the in and out boxes. How to fill the chart. Step 1, put the operation number right here. Step 2, fill the operation description. And for step 3 to 5, from here to here, fill time for manual, machine, and walk in decimal units, going at 0.001 minute. And you're going to read operation, let's say number 2, that's get new part, is going to take the manual time of 0.054 minute. In step 6, so right here, we fill time in 0.025 minutes. And this is your time scale and your total cycle time. So for operator machine operation improvement, we use this graph. So the time graph we fill by using lines. So for solid line, for manual operator time, dotted line, we use for machine automated time, and a zigzag line we use for walk time to the next operation. The rule sheet, well, it shows a sequence of operation and machines. We use this sheet to communicate the routing instruction to various departments that will perform the work. Here is the example of a route sheet. So first we do the part name, part number, and then put the quantity, and then we put the operation number in sequence, and then operation and tooling is nothing but operation description. In details is what needs to be done is putting right there. And the 6 is your machine number. If you have the machine number, you will write it down right there. So this is just to see what a route sheet looks like. So this is the end of the presentation for chapter 5, and what you really need to know is your flow diagram, your operation chart, and your process chart. Okay.